Yeah. So we're going to estimate population proportions using confidence intervals. So the idea is that we don't know nothing about the population proportion, but we know something about the sample proportion and the sample size. And we want to create a confidence interval around 90%, 95%, 99%, which are the most classic percentages used in confidence intervals. Sometimes you might see like a 85%, 92%, 98%, but those are usually given in terms of just changing different parameters, but it's not really what's used normally. Okay? So here, this is what we have. We have p hat, which is a sample proportion. X is usually number of successful trials, variable, and n is a sample size. So essentially what you want to do is you want to create a confidence interval, and then CL is usually confidence level. So ideally what you're trying to do is you're trying to create a confidence interval. Whereas p hat minus the error is less than p hat plus the error, where E equals the margin of error. And sometimes what they have us do is they give us E is defined to be as z of alpha over 2 times the square root p hat 1 minus p hat over n. Okay, so what happens if we actually know what is the confidence interval instead of actually trying to figure out what is p hat, x, and n given the problem? What if they actually give us an actual confidence interval? How would we construct the E, and how would we construct the p hat? So let me do an example over here to kind of give an idea. Population proportion. So say we give us 3.35 less than P less than 0.65. Find P hat and E. So essentially what you want to do is P hat is going to be defined as your max over 2, and then your min, and then your error is your max min divided by 2. But let me just by that, divided by 2, you get the error, you get that. Give me, and let's see. Let me just double check the formula. See what we have. So the error should, this should be plus and this should be minus. So P hat plus the min, and then the error is max minus min, and that should give us the population proportion. So then here, P hat equals max 0.65 minus 0.35 divided by 2. That should be 0.65, so that's 1.00 divided by 2. And that should be 0.5. And then the error, 0.65 minus 0.35 divided by 2. So that should give me 0.30 divided by 2. So E equals to 0.15. So now this is what we have. So we found that if we're given a population proportion interval, we found how to find the sample proportion, and we found the margin of error if you already know what the population proportion interval is. Okay, so in this case, this video is just to say, instead of finding the actual confidence interval itself, to be able to construct this, what if we want to go backwards and actually find what is P hat and what is the margin of error if we already know what the confidence interval is. Okay. So with that, thank you guys, and we'll create another video.